So welcome back to part 2 of 4.2. So a particle moves along the x-axis with position function s of t equals t squared minus 4t plus 2. So first we want to find the velocity function. And again, it's just the first derivative of that, right? So remember, it's just s prime of t, which in this case would be just 2t minus 4. And then a of t, which is s double, it's v prime of t, right? V prime of t, which is b equal to pretty much, what's that? 2. So it's just a constant. So complete the chart for the first 5 seconds and show where the particle is on the number line. So let's try to figure this out. So again, our function s of t is that one right there. Now again, you guys can do this on Desmos. There's no harm in that. All right. So if you guys go ahead and change the other function that you had already in there, minus 4t. So t squared minus 4t plus 2. And then I have the same values right there. So 2, negative 1, right? So you have all those numbers. I'm just missing one more. I'm just missing s of 5 now. So that would automatically change the values that you guys already set up right here. All right, so let's go back to our notes. So s of t at t equals 2 is equal to, keep moving, sorry about that. So s of 0 would be equal to positive 2. And then 1 is equal to negative 1. S of 2 is equal to negative 2. S of 3 is equal to negative 1. And then S of 4 is equal to positive 2. And S of 5 is equal to positive 7. So now we're going to do the same thing. We're going to plug in these values into our velocity function. So 2 times 2 minus 4 is 0. 2 times 1 is 2 minus 4 gives us negative 2. And then this is 0. No, I'm sorry. This one was just negative 4, negative 2. And then 2 times 2 is 0. I'm sorry, 4 minus 4 is 0. So that won't be the 0. 2 times 3 is 6. Minus 4 gives us positive 2. 4 times 2 is 8. Minus 4 gives us 4. And then finally, 2 times 5 is 10. Minus 4 gives us positive 6. All right. And then the speed, right? This is the speed, not the velocity. That one's just going to be the absolute value of all of these. So we just fill those out. So this would be positive 4, positive 2, 0, 2, 4, and 6. And then the acceleration is constant, right? It's a constant 2, so that always just going to be equal to positive 2. All right, so that's the easy part. Now we're going to describe what happens in each of these situations, right? So the velocity is negative and the acceleration is positive. So again, they're opposing signs. So I'm moving, in this case, I'm moving to the left, right? Moving left. And then I can say, and it's being pulled to the right, right? And being pulled to the right. And then for the next one, we got negative velocity and positive acceleration. So same thing, right? So the particle is moving to the left. So moving left and being pulled to the right because it's the same thing. And then the velocity is 0. So once you guys see the velocity 0, it doesn't really matter what the acceleration is. The object is not moving, okay? So the object is not moving. So the particle stopped. And then the next one, both are positive, right? So remember, we're just looking at velocity and acceleration. So both of those are positive. So I can say the particle moves to the right and is being pulled more to the right. So it keeps going faster, right? So moving to the right and being pulled to the right. All right. And then the next two, same thing, right? So we're looking at the same type of situation. These are positive, right? So therefore, it's the same behavior, right? Moving to the right and then being pulled to the right, all right? So Make sure you guys keep notes of that. And then we want to do the graph for this, right? So for our position, this would be the bottom one. So this is for S of t. Okay, so we're going to do that first. So here we're looking at 2. So that was first right there. And that's when t equals 0. -1 is when t equals 1. -2 is when t equals +2. 3 when t equals -1. I'm sorry, backwards. T equals 3. The position is equal to -1. And then t equals 4, position is 2. So that would be also 4 here. And then finally 7 when t equals 5. All right. So the work we did in example 2 is a bit much, but luckily we can simplify it. In general, we are concerned with what direction the particle is moving and when it stopped. And third and finally, when is it speeding up or slowing down? So fill in each box with either the number of phrases speeding up, slowing down, constant speed, or stopped. So if the velocity is positive and the acceleration is positive, in this case, since both are going in the same direction, then we would say it's speeding up. All right, it's going faster. If the acceleration is negative, that means it's going to be slowing down. All right, it's going in the opposite direction. It's like you pushing the brake on the car. And if the acceleration is 0, we can say that it's going at a constant speed, right? So it's like you putting the cruise control on the car. All right. And then for v of t is less than 0. So in this case, this one's negative, and now the next one's positive. So we can say slowing down now. Slowing down. And then both of these are negative. So we're going to say it's speeding up, right? So speeding up because both of them are going in the same direction. And then this one is it's negative and this one's 0. So that means we're going at a constant speed. All right. And then when the velocity is 0, that means we said before, the object is not moving. So it doesn't matter whether this is positive or negative, the object has stopped moving. All right. And then pretty much, let's look at the example 3 right there. So to determine the intervals where the particles are slowing down and speeding up, we generate a sign chart for velocity, a sign chart for acceleration, and a third sign chart, which we call motion, which is a product of the first two. So the graph below models the velocity of a bug on an interval between 0 and 13. So find v of 3. All right, find v of 3 and v of 11. So what we want to do is we're giving the v of t, right? This is v of t. Don't forget that. So if we're looking at 3, in this case, it's +6. So v of 3 equals 6. V of 11 is equal to, let us see, right there, -2. All right. And then the acceleration. So the acceleration is the prime, right? So a of t is the first derivative of velocity. So what we want to do here is just find the slope at 1. So here at 1, for me to go back to the next point, right? The next point on the grid would be just 2 over 1. So a of 1 equals +2. A of 5, if you notice, it's horizontal right there. So the slope there would be 0. And then a of 9 is equal to -3. So in part C, at what time does the bug turn around? So give a reason for your answer. So here we want to make sure that we're looking to see when the bug changes direction, all right? So when is the velocity changing from positive to negative? That's what matters here. So we're looking to see, remember, this is the graph of v of t. So anything above the x-axis is positive, anything below the x-axis is negative. So which point, if you guys notice, there's only one value here where the velocity changes sign, which in this case happens to be when it's equal to 0, right, when t equals 9. So when t equals 9, we can say the bug turns around the bug turns around, right? Because V of t changes from positive to negative. All right. If t equals 9, the bug turns around because V of t changes from positive to negative. So on what interval does the bug have a negative acceleration? So that means we have to look at two things here. The first one is when is the velocity decreasing, and when is the acceleration negative. So look to see when is the acceleration negative, and that's when we have a negative slope. And then when is the velocity decreasing? That's when it's pretty much starting to go down, right? So if you guys look at the graph here, we start to go down. The values of B of t start to go decrease, and then the acceleration starts to turn negative. So pretty much that's when we would say that's the given interval, right? So we can say A of t, when A of t equals V prime of t, right, is less than 0. So that means both have to be negative, right, or decreasing. So velocity is decreasing, and then it's pretty much in the interval from 7 to 10, right?